Hi to all, nice to meet you all together. I'm from Mechatronics, and we're manufacturer of different kinds of sensors for telematic solutions. I'm not going to tell about sensors because there are too many of them. Just all you need to know, if you need to measure something, you can contact us, and most likely we will find solution whether your project is simple or complex. I'm gonna talk about a bit new market, maybe a new market for telematics. Most of us works with secondary market vehicles. So your customers are fleet owners who has bought the vehicle from factory and you install it as extra equipment later. But there is a good market to cooperate with vehicle manufacturers. But these customers have a bit different requests from telematics system. And main request is how to reduce warranty expenses, because vehicle manufacturers should replace broken parts. They should send their team on site to solve the problem. There are big expenses, and every vehicle manufacturer wants to reduce these cases as many as possible. So all we can to do is to use telematics data for that purpose. And there are two data sources to make that. First data source is operation parameters monitoring. So we just can collect the data of RPM, speed, temperature of oil, water, etc. It's a well-known problem, and we can do it. And second data source is self-diagnostic codes, because if vehicles has CAN bus, there are a lot of electronic units sending self-diagnostic codes. And we also can catch them and transmit to the server. And based on this data, service department of vehicle manufacturer can decide and avoid some not necessary warranty expenses and cases. So in that manner, your customer, your vehicle manufacturer can save his money. From the other side, there is a fleet owner, and he is going to get a factory-installed tracking system, and it's very good because it's installed in the best way, because only manufacturer can place all the things of telematic system, hardware parts in the best places. He can do some adoption of his design. So he can install also some peripherals like sensors, fuel monitoring sensors, XLO sensors. So when system is installed on factory, it's always better than our installations on secondary market. But there is a main issue that when a fleet owner gets vehicle equipped on factory, he should get this data in his telematics platform, because if there are two different telematic clouds with that data, it's not very useful to use data part of his fleet is first platform and second part of fleet is another platform. Very difficult integration, and our cloud server of manufacturer should be able to forward the data to as many telematic platforms as possible. And here is a Wialon and FlashPay advantage, because we can resend our telematics data to almost any telematics platform presented on market, so we should not worry about compatibility. And here we come to first problem we faced. We have completed this project for about 1 year. First problem that common GPS tracking devices can read sensor data, can read CAN bus data, but there is an issue with G9039 diagnostic messages because there are almost no trackers on market who can do that properly. Why this happens? If vehicle has only one error, for example, one sensor is not operates correctly, there is no problem because there is a standard parameter group number of SAE standard, and there is standard description how to decode it, and there is a main important fields are suspect parameter number and failure mode indicator. So we can read it with any device like Teltonika, Galileo, Sky, etc. So suspect parameter number tell where a problem is, and failure mode identifier describes the scale of this problem. So we can set up Teltonika to read this data, and everything is okay. But when a vehicle has two or more errors at the same time, for example, several sensors are not okay, several errors, the special transport protocol is applied. And in this case, we don't have CAN bus identifier to fill up in your GPS tracker settings because this message is transmitted into the special transport protocol, and CAN bus identifier is similar and transmitted one after another. It's a very big transport message, and GPS tracker should get all this message, then assemble it, and only then send all this big string to the server. So we have found only 2 GPS trackers on market who can do that. And here is the second problem. Here is the example of strings we have got on Wialon side. First string is example with 2 diagnostic codes, then 3 and 4. So here is a text string with not constant length, and we need to cut it on parts and find the failure mode identifier from each part. So we was not able to find Wialon features to do that, so we were forced to make our own diagnostic server, pulling data from Wialon and calculating by ourselves SPN and FMI. Also, we produced a mobile app for servicemen to look on that in convenient way. So total project looks like big tractors equipped by powerful Caterpillar Deutz diesels, GPS tracker with 2 CAN bus interfaces at least, because there can be separate CAN bus of engine and transmission at least. Also CAN bus of implements can be present, so at least 2 CAN bus interfaces is needed, and multi-packet protocol support. Also, we have our flow meters installed on factory, because when you order sensors installed on factory, you don't need to care about warranty, because it's installed already. And on software side, we have Wialon as data collection point, and Wialon forwards the telematics data to the customer platform. Also our diagnostic server as decoder of diagnostic messages and mobile app for servicemen. As a result, customer and user, fleet owner, he is going to get advanced telematics data, good fuel consumption monitoring, and compatibility with existing fleet tracking system of customer. And vehicle manufacturer, he receives the knowledge how operates his vehicle. He can reduce his expenses on warranty violations. He can cut as many warranty cases as possible. Also, he can use the telematics data as data source to understand how his vehicle operates, to improve his machinery. So, thank you for attention.